Welcome back. The question is explain why the angle of contact of mercury with glass is obtuse while that of water with glass is acute. So this is the diagram where TLSL represents the surface tension corresponding to the solid liquid layer. TLA represents the surface tension corresponding to liquid air layer, and TSA represents surface tension corresponding to solid air layer, and the angle of contact is theta. Since the liquid is not flowing over the solid surface, the components of TSL, which is this, TLA, which is this, and TSA, which is this, along the solid surface must cancel out each other. And for that reason, we get this particular equation, which says TSL plus TLA cos theta equals TSA. So from here we can get the value of cos theta, which is TSA minus TSL divided by TLA. In case of mercury, TSA is less than TSL and therefore cos theta is less than 0, and therefore theta is greater than pi by 2, that is the angle of contact of mercury with glass is obtuse. Explain why water on a clean glass surface tends to spread out while mercury on the same surface tends to form drops. Put differently, water wets glass while mercury does not. Cohesive forces between water molecules is much lesser than adhesive forces between water and glass molecules, and that's why water tends to spread out on glass, whereas cohesive forces within mercury is comparable to adhesive forces between mercury and glass, and that's why mercury tends to form drops. Explain why surface tension of a liquid is independent of the area of the surface. Surface tension is the force acting per unit length at the interface of a liquid and another surface. Since the force itself is independent of area, the surface tension is also independent of area. Explain why water with detergent dissolved in it should have small angles of contact. As we know, detergent with water rises very fast in capillaries of clothes, which is only possible when cosine of the angle of contact is the large. That is, angle of contact must be small. Explain why a drop of liquid under no external forces is always spherical in shape. While in a spherical shape, the surface area of the drop of liquid will be minimum, and thus the surface energy would be minimum. A system always tends to be in a state of minimum energy, and that's why in the absence of external forces, a drop of liquid is always spherical in shape.